be easy. Mine has 22. Probably that's the easier one. Let's see. Let me check the midterm actually again. So problem one wasn't that hard either. Problem one was easy actually, wasn't it? So problem one was one of the like finding master theorem. Problem one wasn't that hard either. So yeah, problem two, that was the one that I explained in the class too. So I think I mentioned a few times to look at the bad sort, and you remember everything I have it in the midterm was, if you go back to look at lecture 11, I already explained everything is gonna be in the midterm, exact format of the question. So I just explained bad sort there. It was a little easier there because it was not open book. So probably for final two, the day I'm gonna explain everything, the question is gonna be quite similar. So be ready for the quite similar question in the exam. So, and about question three, that wasn't that hard. So because it was open book, so you just could plot them. That wasn't that hard. You could just plot them and compare them together. Yeah, so it needs like putting effort to plot them or find like the limit, just finding your limit. Probably problem 3 and 4 wasn't that hard. Yeah. So maybe most of your focus should be on problem 2. Let me see, let me grade you guys. So it's just really challenging because this class has 32 students. So going through all of this homework one by one, it's not that, it takes time. So I'm grading homeworks already. So yeah, I'm grading one every first question for all of you guys. So that's the reason I can't post anything. So I will post them soon. So anybody has any question up to now? Nothing? Okay. Okay. But based on the midterm, did you learn about the topic of runtime, like so divide and conquer? You guys have like master theorem, am I right? That was the purpose, whole purpose of the midterm. Like you guys go and read about this. How do you feel about that? Sounds good? Okay. Let's see. Let me grade the midterm and the homework. Let's see how did you guys do, and then we'll see about the final exam. Does anybody know what is the day of final exam? I think there is like in the website there should be a day that shows what is the day for the exam. Does anybody know? So June 30th. Okay. Okay, let's see. Okay, let's start. I think we wait for 5 minutes. So let me go back. So and then remind you guys what I teach earlier. So we talk about, like, you remember, we talk about quick sort, and then I explain everything before the midterm about how the quick sort works. And then I talk about when you do quick sort, we do partition. It means finding the pivot just from right to left. So okay, everything is smaller than pivot, everything bigger than pivot, and some of the things that was already unknown. So, but you remember, when I talk about quick sort, I say, okay, in worst case scenario, it means everything is already sorted. If I do the partition and quick sort, it's gonna be probably a worst case scenario. And I talk about average, and I say, okay, we say everything is the likelihood of everything happening is gonna be the same, and I explain everything. But let's see. If I want to choose a random, so let's see. We wanna choose random. If we want to talk about randomization. If you want to choose any of these, you remember, any of these pivot sort, instead of just calculating that one, so I want to write them, I want to choose them randomly. So let's see, choose a random element as pivot. Instead of just choosing, you remember, we go through all of them. We chose one of them, the last one, and just go through all of them. So, okay, this is going to be the previous one and go back. So let's see, if I choose them random as a pivot in partition, instead of just choosing them based on what we have in the past, go back and forth and move them, let's do random. What does that mean? So instead of that one, we have another algorithm. So I can write it. It's going to be rand partition. Is it way better? So is it gonna be a smaller better, or if it's in focus, is zooming better? Which one is better? Nobody? What do you mean? So I'm talking about if you want to have a bigger version of the like seeing the notes, or do you prefer the smaller? I don't know if anybody of this is in the class. Nothing? So I'm talking about when I'm writing, you can see my screen. I'm talking about, do you prefer it when it's bigger or it's a smaller version? So is it zoom out? Which one is better? Oh, you like this one more? Okay. Just want to make sure. Okay, sounds good. Okay. When I talk about random partition, it just, okay. First of all, what we do, okay, we say, okay, find something random. It means rand from the start point and the last point, because this is the indexes of A. So find something random, and you remember, we swap everything. So, okay, remove AI and then swap it at AI. It means from the last one and the previous one, just swap them. So, and then return, this is gonna be what? Return the previous partition. We discussed about partition. Partition was showing that some of the data is gonna be less than this value, some of them more, and some of them is unknown. But the previous time, how we chose that Q, you remember, we divide and find the Q. But here, instead of doing that, instead of finding, considering at the end, we just find it randomly. Every time you find it randomly, because every time the pivot was the last number, you remember that was AR, and this time we just randomly choose any of the elements, check it, change it with the last one, which means the pivot gonna change, and when we do the partition based on the new pivot. So that's the first way to do these things. But if we change this one, if we have a randomness choosing pivot, so what's going to happen? It means that we use this partition for quicksort. It means that we have, instead of quicksort, now we have run quicksort. It means this quicksort that we already have in the past, it's gonna have some randomness. So it's gonna be A, again, P and R. So what's going to happen? First of all, what we did in the past for the quicksort, okay, if P is less than R, what we are gonna do? In the next step, you remember, we find the Q, which was the pivot. We do the run. Instead of doing partition, we do run partition, which get A, P, and R. We find Q, and then we do two different steps. It means we do divide and conquer. This is divide and conquer because we do it in two steps, a smaller problem. So run quicksort, and what it does, it just gets A, P, and Q minus 1. And then what is the next one? It's gonna get, again, run the same code, quick sort. What is it gonna do? This one is gonna get A, Q plus 1, and R. That's the way we do this version. So it's gonna be run quicksort. Does it make sense? Okay. So this is one of the things that we explained. We explained about quicksort. We talk about if you how to do random, and then we want to do this. Okay, let's try an algorithm. So I have a question. Then let's try to solve this question. What is my question? So, okay. Like example. What is my example gonna ask? It says write a function, write a like algorithm. What is the name of algorithm? Is min max. What does that mean? It means you find the min and max of the any list or array. So find both min and max. So first of all, if I want to do this thing, let me write two things. You want two things actually. Two steps. What is max of x and y? And what is mean of x and y? First of all, we need to define this. How do you define this one as an algorithm? So if you think this is an algorithm. Here, for the first one, actually, if we do max, we return, what do we return? We return x greater than y. If you find max, if it's this one or like y greater than one of these ones with the maximum of two numbers. So how many comparisons do we have if you consider the number of when we compare them is one, because you compare them one time. So that's the first one. Let's finish this one. So let me see if I can write it better so I see it. Okay. So this one has one. Let's write the other one. How about mean of x of one? This one, what it does is just return again x less than y or y less than x. Which one is whole? So any of these gonna hold. So how about this? It's gonna be the number of comparison again. It's gonna be only one because consider only one. But let's put them together. Let's put this algorithm together. I know what is mean. I know what is max do. But how do I find this one as a pseudocode like for any array? So because I do have an array, so it's not two numbers. Here we just consider two numbers. So, but if it's not only two numbers, like an array of so many numbers, how do you consider that? So you need to write it and find the like cost. So what are we gonna do here? Let's write. It's like, okay, if I want to write mean, let me see. Okay, was it smaller? And then this is capital. So mean max of algorithm A, P, and R. So the prerequisite, first of all, is to get that P is less than R. It means that the index is gonna be less than R. How do we do these things? Okay, let me write. Actually, let me see this one a little distance. We need something else. It's gonna be P less than R. So what is the first step? What do you think? I give you like this one. Let me write it here. It's gonna be like 2, 3 minus 1, 5, 6, 7, 8. Or any array. How to approach it? Think about these things that it's gonna be what? It's gonna be called by itself. It's gonna call itself again and again because it's like a divide and conquer. When we divide and conquer words, it means it's gonna call itself again. So for divide and conquer, you remember I told you guys, if you could recall same algorithm in the loop, what you need to do, you need to have a stop point because you are gonna call it. So how do you write a stop point here? So because every time if I run it as a like a divide and conquer, I need to stop somewhere. What do you want? What do you want as a stop point for this algorithm? How do you approach that? When do you stop? Things that I have this array, I want to do it truncated, do it a smaller portion instead of the whole, make it a smaller, and then find min max. When do you stop? How smaller do you make it? Anybody? It's okay if you what you think is not right. Just think about if I make this array smaller, how smaller can I get? Nobody? Is it clear what I'm talking about? So the question is, okay, I have this array. I asked you guys to find the mean and max at the same time for me. So look at this array. Okay, first of all, what is the mean and max of this array? If I get asked you guys to return it, what is the mean, what is max? Yes, mean is -1, max is 8. That's as a human you can do. Okay, for solving this problem, I explained earlier. Instead of, so if it's 1 million, look, if this number was million of the element, that we have million elements, it was really hard to look at them on million. Maybe you can't divide it. It's just okay. Let's consider 20. Like if like not 1 million. If you have 20 of them, probably was harder. You just look at the 10 of them first, and then go smaller. So maybe I start with when you have 20. I say okay, 20 is too much. Let's look at 10. And then you see, okay, 10 is too much. Let's look at 5. When is what is the smallest number from this problem I can get? So what is the smallest? Yeah, you're right. But probably we can do something better than 2. So for example, the last thing we can do, yeah, 2 is going to be 1, but we can go smaller than 2. Maybe how about 1? If we have only one element, if we go to 0 element, so there is nothing to compare. But if I have only one element, it means look at my array. If it has only one element, so it can be both max and both min. It means that I can go until one element. So what I'm going to say, okay, the first, like, this is what I'm going to write here. This is the base. It means that I'm not going to go smaller than this. That is the stop sign for me. It means I make my algorithm smaller and smaller, and I'm going to end it up here. What does that mean? Okay, if the start and the end is the same. If that's the case, what we are going to return? We have only one element. Why I say 2 is not good? Because if you have 2, you still need to compare it. We don't want to compare anything. Here we are writing the algorithm that call itself that call itself a few times. So if I have only one, there's nothing to compare. So again, if I have only one element, so the mean is going to be that AP, and the max is going to be that one too, because there is only one element. So that's the first case. But let's see. If it's not a case, it means I have more than one element. What do I do? Like the past, we are going to divide this algorithm. We are going to make it smaller. How do we do this one? We say, okay, like a past, P and R divide by 2, it means go to the half of that. And then what we are going to do? We are going to call the algorithm again, because we are going to do the min max. Okay, min max, call it, this time on a smaller portion. call it from A, P to Q. And then what do we find here? If you call this one, there's something that needs to, that return. So first one, what is the first one that will return? The first one is gonna be M, which is gonna be minimum. Capital M, it means there is a maximum. So this is gonna be return, min, max. It's gonna from what? From A, P to Q. That's the first one. And then next time, what I'm gonna do, I will find this part, which is gonna be calling again, min max. And what it's gonna do, it's gonna start from A, Q plus 1 to R, all the way go to R. So now, instead of solving this problem, I just divide this one. It means this portion, I did this portion, and I did this portion. Q was like 5. Q was this one. This indices. So I did this one. I find min max here. What is the min max? It's going to be minus 1, 5. And here I have min is 6, max is 8. What do we need? If I do have these two, what I need to do, I need to find the minimum between these two. What I'm going to do, I'm going to do this one. I'm going to return, because now everything is here. So what I'm going to do, I'm going to call mean. Remember, I write mean function here, mean and max, because it's only two number, mean between M1 and M2, and what is max? Max between M1 and M2. So this algorithm, what it does, it runs it by itself. A start, if it's only one element, makes me the max and min is equal, and then I divide it by one smaller, and right. When you, that's the thing about like this kind of algorithm. Let's for one time solve this problem. Let's do it by us together. So, okay. Okay, let's write it here. So what is A? A was what? A was, let me write it, 2, 3, minus 1, 5, 6, 7, and 8. When you call this algorithm, first of all, what it does, you say, okay, let me write this one. What is P here? P is number 1. What is R? What is number R? Anybody, what is number R? Okay, 7, correct. So when you call this algorithm, how it works, the first time is okay, if 1 and 7 is equal, no. If it's not equal, let's find the first step. Let's write the first step. What it does is, okay, Q, what is Q in the first step? We say 7 plus 1, 8 divided by 2, which is gonna be 4. It means Q is gonna be number 4. What is number 4? 1, 2, 3, 4. It means it's gonna be A4, which is gonna be number 5. We do have this one. We know Q is 5. What it does is, in the next step, is they find M1, M, min, max from A, which we know A, but from where? From number 1, this time up to Q, to 4. What it does, now this is calling the algorithm again. Before going to number 6, you need to call the algorithm. So I call the algorithm. So this time I do have what? I have 2, 3, minus 1, and 5. This time if I call the algorithm, I'll say, okay, this is the new P for this one. This is P, and this is number R for this one. When we call it again. So when you call this one, this time this Q is gonna be there. Okay, this is gonna be P, which is gonna be 1. This is gonna be R for the next round, which is gonna be what? Which is gonna be number 4. Let's do this step again. If P and R is equal, no, it's not. Let's do this one. What is gonna be Q here this time? This time Q is gonna be 5 divided by 2, which is gonna be number 2. So, okay, I say, okay, do number 2. let's find again. So if I go here, I need to do another M. M inside this one, this step is gonna be another M1, M2, which is gonna be min max of what? Again, A, and from where? From 1 to 2. So I need to, I'm not gonna move forward again. What I'm gonna do, I'm gonna calculate this one. Go back, min max. This time what is A? This time when I call it, this time my A is gonna be what? It's gonna be 1 and 2, which is gonna be number 2 and 3 only. 2 and 3. Again, I'm gonna call this algorithm. It's okay. P is gonna be what? P is gonna be 1, R is gonna be 2. Okay, are they equal? No. So what I'm gonna do, next time this is gonna be Q. What is gonna be the Q? Q is gonna be 3 divided by 1 is gonna be 1. It means next time when I'm gonna call it, I'm gonna do what? I'm gonna do min max of what? A, 1 and 1. This one is gonna be Q because it's okay, APQ. This time when I'm calling the algorithm, A is gonna be number 2 only. So what is gonna this shows, because this is gonna show this one, it's okay. I reach here, so I'm gonna return AP and AP. So this time from here, M1, M1, and M1, we can put a step like here. So this is gonna be M1, M1, step 1, and this is gonna be M1, 2, 2, and this is gonna be M1, 3, 1. It means in this step, I know this is gonna be 2 and 2. So I found this one, so this is done. Now what is the next step? If I found this one, I need to find that. I think I found this part. Now I go to the next part. What is min max? I calculate this one. Now I need to do min max of what? This time is gonna continue this part. A from 3 to what? Where was it? What was it? 3 to 4. So now I know minimum and maximum is gonna be 2. Now I will do this part. What is this part? Number 3. This element was 3. So yes, so it's gonna be here, 2 and 2. This time it's gonna be 2 and 2. Now this, if I go here, is I'm gonna read this number 3. So min max in this step again, for step 4, is gonna be 3 and 3. So now I did one algorithm finish. I did this part, this part, this part. Now I need to return. So now between these 2 and 3, which is the smaller sub problem, now what I'm gonna return, I'm gonna return M, a small, so I put it this M prime and M prime. This time is gonna be 2 and 3. It means all this step gonna show what? This sub problem, the mean is 2, the max is 3. You just calculate this part. Now you need to do level up. So we did this part. Now we need to find this one too. If we find this one, we find mean is gonna be -1 and max is gonna be 5. So what do? Between these and these, you get between this mean, which is gonna be -1 and 2, you find another mean between this max, you find another, and you will go level up to when you finish this algorithm. You know, every time you call it by itself. Does it make sense? Is it clear now how it works? You just go one step, is call itself, and then I think I suggest you guys do it one time. Just do all the steps for one algorithm for this one to understand how it's called itself a few times, and you will get how it works. Does it make sense? Clear? Okay. So if it's clear, the reason I'm talking about this one, I'm gonna go to like dynamic programming. I want you guys to understand the concept of like, this is the concept of divide and conquer, because you just make it smaller, smaller. Okay, let's find the cost. Cost from comparison. What is the cost of the first one? Okay, yeah, correct. The first one is 0. How about the second one? That return. You remember the cost coming from if it depends on the length of the algorithm by itself or the length of the array. What is the cost of the second one? Okay, yes, 0. How about the last? This else? Else doesn't have anything. How about Q? Q still doesn't belong to. And how about this one? This man min max. You remember I explained if this is T, this is gonna be T n over 2 because it's considered Q. It have Q, that's gonna be filling, and this part is still is gonna be half, but it's gonna be filler because it doesn't have Q. And this last one, actually, as we remember, we saw the first one have one comparison, the second one has one, because you do one for me, one for max, it's gonna be 2. That's the way it does work. Is it clear? Anybody has any question? No question at all? You don't have any questions, or should I move forward? Jonathan, it's okay. No worries, I understand. That's fine. Okay, so let's go. Okay, let's find Tn. Tn is gonna be number of costs or number of comparison on what? A from one to n, when we have n elements. So let's do this one, Tn. If I don't have only one element, there is nothing to compare. Min and max is gonna be the same. So it's gonna be 0. So we say, okay, if we have 2 elements, what we do? Let's go back here and write this one. This summation is gonna be T and this one, and then gonna be lower, and then number 2. We have this thing. So as we remember, we talk about we can drop this floor and ceiling and this number. So what is gonna be? It's gonna be like T of n. We say, oops, okay, T of n is gonna be what? It's gonna be 2T of n over 2 plus 2. Okay, let's see how it works. So you remember we talked about the smiley face. Okay, so how do we do this one? We can consider a smiley face. So go T, a smiley face, gonna be 2T, a smiley face divided by 2 plus 2. If I keep putting this one and move forward, I'm gonna end. It's gonna be T of n, it's gonna be 2 n minus 1, n minus 1. If you keep going calculating, so it means putting here, just plug it in and then go again and again, it's gonna be T of n. This is gonna be the definition. So based on the definition that we have, so if I don't go through this one to calculate, what is gonna be this one? If I wanna show this one, it's gonna be theta of n, because I explained about asymptotic notation, we talk about numbers. So between these two is not important, and then -1 compared to n is faster, so it's become q, like big note, theta notation of n. Does it make sense? You guys understand? Okay, let's just give you one moment. So let's talk about one. So, okay, I want to talk about one more concept, and then we are going to move forward with dynamic program. I want to think about an algorithm which has become famous because of their author. So let's start from something completely. We finished this one algorithm. Let's talk about something. Consider what is the thing. Let's see. Consider 2n by n a square matrices, which is going to be A and B, and multiplying them. Multiplying them. So let's consider element C, which is going to be A and B. So let's recall it. How do we calculate this one? If you want to find C, let's see. C, I, and J. How do you find C, I, and J? If you find any element in I and J, do you remember how do we do it? How do we, when you multiply two matrix, any elements of that third matrix, how it's going to be calculated? Like, for example, if I do have let me write it. 1, 2, 3, 4, 5, 6, 7, 8. If you want to find C, how do you find C? These. How do you multiply these two and reach to C? For example, this is going to be C. This is C11. How do you find C11 actually? Anybody? This is coming from basic, I think, math. No idea. Okay. It's when you do CIJ, so this one is coming from first one, this one is going to be 1 to 5, 2 to 7, actually. So, but yes, there is the way you do it, you say, okay, from K from 1 to N, it's going to be AK and BKJ. How it works, for example, if we are going to do 0, like 1, 1, when you do like C11, the summation is going to be from 1 to how many elements? To A1K, BK1. What does that mean? It means the whole row, this row, and this is whole column is going to be 1 by 1. So that's the way you do it. Let's put this one as an example. I don't think we need this one. So what do we do? This is the way. So this is for what? For all I between 1, for all I between 1 to N, and J between 1 to N. As you can see, how many numbers? If I want to find the runtime, let's see. Finding a runtime. How long does it take to finish this one? Because you have basic operation of what? So we do multiplication, multiply everything of floating numbers. Floating point numbers So what is gonna be the algorithm? It's gonna be the algorithm runs in runtime of theta and q, because you multiply from 2 times 1 by 1 and do the summation, so it's gonna be n q. So we say, okay, I know it's bad because we don't divide and conquer to do it. We do it all 1 by 1, just do multiplication and everything. It's gonna be bad. We know that n cube is not good runtime. I say, okay, I know what we did divide. Let's do divide and conquer. This is the first we learn about like doing everything. Now, okay, I learned about divide and conquer. I want to solve this problem on divide and conquer. It means divide it to sub-example. Okay, what was the case? It's okay, case is n is exact power of 2. Because you want to divide it, exact power of 2. What does that mean? It means I can divide it to 2. This is gonna be, if I divide this one, actually, the whole matrix, this is gonna be A11, this is gonna be A12, A21, A22. I divide my matrix because I know the size. Now any of these gonna be n by 2, multiple n by 2, because we say this is power of 2. You just divide everything. And how about B? Let's do exact same thing for B. B is gonna be B11, B12, B21, and B22. So now we do have this one too. So the size is going to be exact same thing. But let's see. If I want to C11, again, it's going to be A11 plus B11. Sorry, not plus, multiple. Multiple B11, and then A12, B21, because we do these things. First, our first row is going to be multiple of second column. First column is going to A11, B11, A12, B21. So that's the first one. Let's do C21. It's going to be A11, E12, A12, B22. And then the second one, 21, is going to be A21, B11, A22, B21, and then C22 is going to be A21, B12, and then A22, B22. So I will calculate everything, and then we say, okay, let's see. Be this one, C11, C12, C21, and C22. If you prove it, if you go through all of these things, so this is actually, this is the exact same of what we did in the past. If you calculate T of n for this one, actually, it's gonna be number of basic operations. How many operations do we do? Exact same thing about the previous. Necessary, basic, necessary, necessary on matrices of size n by n. That's a number of things we need to do. So probably I will remove this one. Basic operation. Okay, so we calculate this one. This is going to be T of n is equal. If n is equal to 1, it means it's not a matrix. It's going to be 1. There's nothing. It's only one operation, just multiple by 1. But if n is greater than 2, and n should be the power of 2, you remember I explained. This is going to be 8t n over 2 plus 1. This one, this is the constant. This number is the constant of dividing, because we divide this thing. This is going to be cost of dividing and combining, because we divided and we combining. So If it, now we know T of n is gonna be 8 T of n over 2 plus 1. If I use master theorem, what is gonna be the result if we use master theorem? If you use master theorem, what are you gonna get? You guys have exam yesterday, you should know the math.
Case one?
Mm-hmm.
That's my
Case one,
guess.
yes, what is a case one?
That's what happens when the log A over B is more than the power of f of n.
Yeah, it's gonna be log of what? It's gonna be
Not
log
A over B, it's A log base B.
Okay, so what is gonna be the result? It's gonna be theta of what?
I don't remember, sorry. Let me look at my notes.
It's gonna be, you're so lucky the exam was like open book. How it's gonna respond to it if you don't remember it?
I'm lucky or I planned well.
You guys, I don't know. You guys are lucky that you don't need to just memorize everything. So it was like open book. Okay, so now we found it. Okay. The whole structure of this thing is that, you see, I just did it in one round. I said, okay, let's do it in one round. I found the runtime is this one. I said, okay, do the divide and conquer. Most of the time, divide and conquer give us better results. So we did a divide and conquer, exact same result. It means our divide and conquer didn't help. We say no improvement. So divide and conquer didn't help. So that was when in 1990, what happened? In 1996, 1969, there was a person, so it's like Walker, and hopefully I pronounce it right, Preston. Find an algorithm. It's this person find this algorithm. This algorithm try to prove this calculation. So this is what he did. That's the reason the name of the algorithm is Preston. So but he figured it out to do the better job. Figured out how to do this. So look at this one. It says we divide it and do it in 8 times. When we divide the algorithm, divide the whole problem to 2, we need 8 different operations, sub-operation. But what it says, okay, this is, he can do this with only 7 instead of 8, 7 sub-matrices. So I can do it in 7. So if that's the case, if this is we can do in 7, what we get? So we get this one instead. T of n is gonna be 1 when is n equal to 1, and then it's gonna be n greater than 2, and n is gonna be 2 power of k, so this is gonna be 7 instead of 8. So if it's gonna be 7, what's going to happen? Let's do the master theorem again. So how about this time? What does master theorem say this time? It's still case 1, yes, correct, because we say, okay, we say n log 7 to 2. to n power of 0, okay, case 1. But what is the number? This time p of n is going to be theta of what? It's going to be n log this log, n ab. This time it's going to be n 2.8. It's going to be smaller than 2.3. Instead of theta, it's going to be a small o of n3. It's better. It's not theta of 2, 3, it's 2.8. It's a little better, so it's going to be better than original. We found this one, so okay, that's better original. And then he explained if there is a way, if n is not exact power of 2, how we divide everything. So I'm not going to go to that details because the purpose is talking why like this is going to work, why dynamic program. This is the way that it does it. It means that if you find a way to do the better job, probably we are going to get the better runtime. So that's the only purpose of everything we explained here. But this is coming how to solve this thing. This is solved with dynamic programs. So we are going to go back to dynamic programs. Okay, what is actually dynamic programming is? Why do we think it's important to know? So anybody has any question up to now? Or should I move forward with dynamic programming? No question? You guys are good? It's really, I don't know, it's really weird because, I don't know, funny because how many are you guys in the chat? In the phone call? 20, I think 19. And sometimes none of you guys respond. So and I don't know, are you guys listening? Are you there? Or you are not there? So that's the thing. Like, I don't know. Do I explain to myself? So probably at least yes and no. So I think I know at least 2, I don't know, N, or I don't know how many of you guys listening because I don't know what's going on. So, okay, sounds good. Okay, let's go to one of the really important problems. So we talked about divide and conquer. So as I explained earlier, like we use divide and conquer a lot in our life because it's hard to do everything at the same really big portion. We make it smaller. It's easier for a human to do it, and easier for machine to do it too. Maybe you can do it faster. Instead of just going through one by one, you do it in a smaller portion and it's going to be faster. But there is another way. Okay. Let me ask you something. So, for things that you live in like downtown area of like San Diego, and there are 2 different places really close by. It's far from your place, like downtown area, but they are close by. So do you think if I want to go to there, so is it really, does it make sense that I go there? If, for example, I plan to go both of them, both of the places, it doesn't make sense. They're far from my house, but it's really close to each other. So does it make sense that I start from my house? So let me write. So let's see. I live here in location A, and this location B and C are closer, as you can see based on this distance. So what I can do one time, I can do one A to B, and then, no, probably something better. Let me do something better. Yeah, let's see. I'm here, we have A, we have B and C. Let me see, this is better actually. I'm trying to explain something. So this is A, this is B, and this is C. You see, B and C are far from A. So does it make sense for me to go and do this one? And that's probably the better things to do. I'm so sorry. So this is A. This B and C are really close. Does it make sense? I start from A. Oh my gosh, what's happening? Does it make sense? I start from A, go to B, go back home, and again go to C. What is the best? Or is it better that I go from A to B and from B to C and then get back home? What is the most probably which one is better in your opinion? And then I need to go back home. This is which one is better? Okay, yeah. I think it's really obvious. So it's really obvious. It doesn't make sense because B and C are really close. So I can go to B, go to C, and then come back. It's the time I'm gonna spend is gonna be less than what I'm gonna do with the red one. So that's the way dynamic programming works. If something is all this portion, you can see the portion from A to B is already taken. Going to C, you don't need to do these things 2 times. As you can see here, look at the green one. You go from 1 to B, B to C, and do this thing. You know, from 1 to B happens only 1 time. In the second one, which is going to be the red one, calculating 1 to B happens 2 times. You see 2 different ones because 1 time happened for this portion, 1 time happened for this portion. They are exact same thing. So what is dynamic programming suggested? It says you're trying to solve a problem and there is some problem that is they're exact same thing. It just doing the way to repeat itself. So why do you want to calculate? Just keep it instead of just writing it and calculate. Just do it 1 time. So that's this. All the concept of dynamic programming is coming from that. Does it make sense? You just don't want to repeat something you already did, or you can do it 1 time. Is it clear? Actually, let's go to, I explain it in like really easy example. Let's write about the concept. A second. Dynamic programming. What it says is an algorithm design method that can sometimes provide a more efficient solution than divide and conquer. Divide and conquer approach. So let's show an example. So let's computing. I want to compute this one. Computing binomial coefficient. So, but let's if somebody doesn't remember what is binomial coefficient, we say the binomial coefficient. So which one was it? It's gonna be k of n denote. What is denotes? It's using probability a lot. This is the number of k elements set where what? Where k is less than n, greater than 0. And if we have a Pascal's identity says that if k is between 0 and 1, then what we can do? Then we can do this one. K to n is going to be like what? It's going to be k n minus 1, n minus 1, plus k n minus 1. This is the definition. So this, what is this going to identify for us? First of all, this is the definition that we have. We say this is the, we want to find this one, find the n, the number elements set from this one. So what we need to do, this one is going to provide this identity, provides the basis for recursive algorithm. For what? For computing Kn. So first of all, we have initial condition. Because as we say this is gonna be everything calculation. It's gonna be should be greater than 0 and it cannot be n. So the first thing is gonna be this one. The first condition, initial condition 0 or n, which is gonna be n by n, because we cannot have n, because this formulation doesn't work for 0 and n. But we know that if 0 and n by n and n from n, so this is based on the math, we know this is 0. So what we can write this one? Actually, the definition of k of n is gonna be this one. We say if k is 0 or k is n, what's going to happen? It's gonna be 1. If k is between 0 and n, it's gonna be what? K minus 1, a minus, and then what else? It's gonna be n minus 1 and k. Okay, now I know. Is anything unclear here? Anybody has any issue up to here? Because now I'm gonna explain dynamic programming. Is it clear here? It's all math. So anybody, is it clear? It's not clear? Which one? This is 0, yes. It's between 0 and n, yeah. So now what I'm gonna do, writing this one in pseudocode. If I write this one in pseudocode, let me write it in pseudocode. There's gonna be this algorithm. Yeah. What is gonna coefficient, because it's gonna consider coefficient of n and k. How it works? So we have one what? We have one condition. It's gonna be like base condition. If k is equal to 0 or k is equal to, let me do this one better. K is equal to 0 or k is equal to what? N If that's the case, what's going to happen is going to return 1. If it's not the case, else, what it's going to return? It's going to return this one. It's going to return what? It's going to return So what it's going to return is going to call by itself what? It's going to call this one. What is going to call n minus 1, k minus 1, and then plus what? This time it's going to call n minus 1 and k, as you can see here, because this has this summation. It's called by itself. Does it make sense? This pseudocode makes sense. Okay. Let me explain how it works. Let me write it. Let me write it in a way. So let's do this one. So, okay, if I want to write this pseudocode, I have this one. What's going to happen every time I come? So every time I consider this one, the first one is going to be this one, this part. This is the first one. This is the second one. It's going to be k minus 1. Probably a little, maybe a smaller. I think because it's going to be huge. So this is going to be k and n. Let me have it here so we have more. This is going to be k minus 1, and this is going to be n minus 1. And what is this one? It's going to be k n minus 1. What is the next layer? If you want to just write the next layer, how do you write the next layer? Can anybody tell me what is the next layer? What is the next layer? If this is n minus, do you want to call this algorithm again? What's going to happen if you have n minus 1, k minus 1? Let's consider this one. Instead of n, you have n minus 1. What's going to happen? If you have n, and instead of n, you have n minus 1. It's going to be n minus 2, k minus 1. K doesn't, this is going to be n minus 2k. So it means the only n is going to change. K minus, this is going to be n minus 2, k minus 2, because it's going to be less than that. And this is going to be n minus 2, k minus 1. This is the first step. Because everything is changes from this one. Now, how about this one? This time again 2. This is going to be n minus 2, k minus 1. It's going to go one step less. So it's going to be n minus 2 and k. Okay. Let's go one step layer down. So this is going to be what? If I keep going, this is going to be n minus 3, k minus 3, because every time it goes down, it's going one layer down, and this is going to be n minus 3, k minus 2. How about this one? This is going to be again n minus 3, k minus 2. This is going to be n minus 3, k minus 1. And if I keep going, this is going to be n minus 3, k minus 2, and this is going to be n minus 3, k minus 1, and this is going to be n minus 3, k minus 1, and one more. Oh, that's going to be a challenge to put it. If I can write it. Let's see. N minus 3k, and this is going to be n minus 3k minus. Is this clear up to now? Did you guys understand what's going on? I just put every time this is what was nk, I just change them. N minus 1, k minus 1. I just put it here and go all the way down. Does it make sense? So can you see this one? Some of these things in this layer is repeated. So n minus like n minus 3, k minus 2. It's 1 here, 1 here, 1 here. N minus 3, k minus 1, 1 here, 1 here, 1 here. It means that some of these things repeated themselves 3 times in level 3. It means instead of calculating, if you calculate this one, I calculated for these, and these. I don't need to calculate these things 3 times. That's the way that dynamic programming works. You don't need to repeat some problem that you already did. So that's the why it's important about dynamic programming. So we say, okay, if this is the case, let's go and talk about what's going on. So okay, we say observe that at the bottom, if you go all the way to the bottom, you are going to reach to what? N minus n, you reach to 0, 0. So it's going to, at the bottom level, what do we have? At the bottom level, so we have always return 1. So we go always return 1. So what we do, if we go from down to up, it's just adds up a lots of a. So because it's just gonna add up all lots of a from up to lots of a's. So it's gonna from down to up. So it's gonna do all of this one. So the runtime. So when we do these things, so we calculate the runtime. So the runtime is gonna be this one. It's gonna be theta of k of n. So this is gonna be what's going to happen if you want to consider this one. So what we do here actually, so we are trying to understand how we approach this problem. If we already know that this, how many times you're calculating this one, so probably just one more thing. When we do this, we know that this is based on mass, is n factorial, k factorial, n minus k factorial. That's the definition. So we say that everything goes down like this, and then we define this problem, we go all the way down, we have so many subproblems. So the runtime is gonna be the runtime of Kn. We say if K, because you know why? Because every time it's repeated. Let's say if it's gonna power up 2. This is gonna be theta y, 2k k. And if I continue to do these things, it's gonna be, if I based on definition, consider this one is going to be 4k divided by this, if I calculate it. So this runtime is going to be this, 2 to the power of n by square root. So this is going to be exponential, because you see how bad is it? It's exponential runtime. If I do all of this steps. If I do all of them one by one, do it again and do it again, based on, I just consider this one, do some of the calculations, see how bad is it, because runtime of exponential is really bad. So there were, instead, just because not only I calculate this time here one time, I do it here again, I do it here, I just definition. So there should be a more efficient way to do it. So we should do more efficient, because it's bad if it's a random, because if n gets bigger, this is going to be really, really, it takes forever to finish. So we are talking about how to calculate this one in a really, really more efficient approach. So let's give you guys 5 or 6 minute break, so then we will come back and explain about more efficient way before finishing this class. Sounds good? Like 5 or 6 minute break. Okay. I think it sounds good. Am I right? Okay, let's keep going. So before finishing the class. So what is the more efficient way? As I explained, these and these and these, they're exact same way, but they're from different branches. How can I keep track of them? So if they're coming from different branches, it means I'm not gonna see the previous one already. So what is the best way to do it? It means memorize it. It means write it somewhere. The next time I need it, I already have it. I don't need to calculate it again. So that's the reason what's gonna be the efficient way, which is really, really famous, that we use it a lot in dynamic programming. So we say maintain, it's gonna be maintain a table, so it's gonna be maintain a table of intermediate results. What does that mean? So it means that, okay, if I start from here, go level down, from here, go level down, this one, go level. From here, if I calculate this one, let's memorize. Let's have a table. So then next time I need it, I already, if I need it, I have it. When a substance value is needed, first look up in table to see if it is already there. Already is already there, computed. If that's the case, if yes, return it. If yes, return it. And then otherwise, compute and save in table. So it means that this iterative, because you already, this iterative, this that's okay, let's say. The iterative implementing is called dynamic program. So what does that mean? Oh, let's see how, for example, let's calculate one of these and see how it works. So okay. For example, for that one, I just put a table, I make a table. I say, okay, this is gonna be 0, n0. This is one of them is n, one of them is k. So this is go all the way to n. This is go all the way to n2. So let's consider this one. This is the lookup table. Like for example, this is 1. Let's see. For example, this is 0, 1, and all the way to n. This is 1 and 0. For example, I say, okay, if n is 1, 0, and like k is 0, I know this is gonna be 1. And then next time I just do 1 and 0, I just put 0. And if I need it, the next time I come to this table, if I need, this is n, for example, 1, 0, I don't need to calculate. I look at if it's in the table, I know it's already in the table 0, so I don't calculate it. But if it's not in the table, so if it's okay, it's not in the table, I will calculate it and I say, okay, this is gonna be 0, for example. I will put it here. Just keep going. Like this is gonna be 1, 1, for example, 0, 0. Just keep going. Every time I come, if it's there, it's already there. I don't need to calculate. If it's not there, I will calculate and put it there. Does it make sense? For example, yes, let's go back to it. Let's start to make this table. Let's, let's actually let's make it really. I just want to teach you. This table not made memorization because it's gonna memorize. So I wanna do this. I wanna do 2 n is gonna be 3. Let's do this one. This is n and this is 3. Okay? Sounds good? Dynamic program. The way that we calculate this one, this table name memorization. So I will explain. It memorizes everything. This table name, but the program is like dynamic program. So what we do, let's make the table. Okay. So this table, let's make the table actually. So this is K, which is gonna be 0, 1, and 2. This is the first one. This row is gonna be N because it's gonna be like 0, 1, 2, and 3. So let's calculate them. I know by itself what we discussed about it the beginning case. It's gonna be 0 and n, which is gonna be 0 and 3. We know 0 and 3 and what? What else do we know? We know 3 and 3 is gonna be 1. 3 and 3, all of this is gonna be 1. Let's put it there. Let's go 3 and 0. It means n is 3, k is 0. This is gonna be 1. And 3 and 3 is gonna be 1. These two. I already know these two. So what is the next step? If I have, let's go back. Let's do this one. 3, 2. Let's do it together. What was the definition for this one? It's like, okay, this is 3, 2, which is gonna be n, k, n. What is the step? N is equal to, like, I don't write this part. This part you can find it above. What is this gonna be? This is gonna be k, what is that? N minus 1, k minus 1 plus 1. N minus 1k. Okay? Yes, I wrote it from here. That's the case. Let's do it. So I wanna find what? I wanna find this one. 3 to 2, how do you do these things? Let me make it maybe better. Okay, let's do it. 3, 3, 2. Just help me write it. So what is the next round? 3 to 2, what does that mean? So it means the next round, this part is gonna be n minus 1. 3 minus 1 is gonna be 2. 2 minus 1 gonna be 1. And this part, 3 minus 1 is gonna be 2, k is gonna stay 2. That's the first round. And then from this part, what do you do? Oh, second, next part is gonna be this one, n minus 1, which is gonna be 1. And this is gonna be 1 minus 1 is gonna be 0. And this is gonna be what? It's gonna be 1 and 1. That's the first. And then how about this one? 2, 2 is gonna be 1. Did I write it correctly? Yeah, I think I write it correctly. 1 to 2. And then what else? Actually, we don't calculate this one anymore. Am I right? Yeah, I think so. Let's see. I think so. N minus 3, yes. We go all the way to here, yes. This is gonna be what? Yes, it's gonna be 1, 1. And this is gonna be what? It's gonna be 1, 2. Yes, that's correct. So you can see this is gonna be repetition. So I move from here up to here. So I need this one. What is 1, 0? What is 1, 0? If you consider this one, this is gonna be what? Any number from 0 is gonna be 1. I calculate 1, 0. Let's go and put it. It's gonna be N1, K0 is number 1. I will put it here. So I just do this one. 1, 1 is gonna be this one. What is 1, 1? I don't have 1, 1 already. 1, 1 is gonna be 1, 2. So I will put it here. Now, if I go here, what is that? 1, 1. 1, 1 is already calculated. I will look up table, is already calculated. I don't need to calculate it anymore. So here, probably when I reach here, I already know it. I don't calculate it anymore. That's the case. So, and then you do this one, 2, 1, which is gonna be 2, 1 here. Does it make sense? This is gonna be 0. When you have 2, 1, this is gonna be higher, it's gonna be 0. So that's the case. So I calculate now, every time I just want it, I already have some of these things. This 2 is gonna be the summation for the above one. So we have this one, 1, 0. I know it's 1, 1, 0. It's gonna be 1. I think we 1, 0, we didn't calculate. Yeah, did we calculate? 1, 0 is here. Actually, we should put it here. 1, 0 is here plus 1, 1. 1, 1 is 1 here. So we forgot to put this one. So this is gonna be 1. And this is not gonna calculate. And then we do the summation. So this is summation of this is number 2. We put it in here. 2, 1. 2, 1. I think I put it this one. 2, 1. All right. This 2, 1 is gonna be number 2, and that was this one. This one is number 0. So now I already have these, and if I go back here, I have 1, 1, 1. 1, 1 was 1. 1, 2 was 0. This is gonna be 2, 2 is gonna be, what is that? 2, 2 is gonna be number 1. So it's already filling this table. Anytime I need something, if I go one level upper, I already know this. Does it make sense? Okay. Actually, this is gonna, we don't have this one. It's gonna be, we need to calculate this one. It's gonna be 2 to the 3. So is it clear how we do it? We just go all the way down, filling this table. So if you fill this table, then you already have it, and then you can write your pseudocode. I will write the pseudocode next tomorrow, and then explain what is the runtime. How this algorithm, because we remember we solve, if you want to solve this one, we say, okay, this is going to be the runtime. What was the runtime? The runtime is going to be this. If you write it, this is the runtime. This is exponential is bad. Let's see if you use dynamic programming, what's going to be the runtime. Does it make sense? If it makes sense, so I think we are good for today. So hopefully you got what I'm talking about. Dynamic programming. Dynamic program, try to mention if something is already calculated, don't calculate it anymore. We already have it. So that's the reason we have all of these problems. So yeah, so if you don't have any question, have a great evening. Talk to you guys tomorrow.
Professor?
What?
Hi. Do you know if the final is going to be cumulative?
What do you mean? Oh, all the topics? Yes, it's going to be all the topics.
Oh, okay. All right. Thank you.
You're welcome. You're welcome. It's a dynamic programming. I don't remember the chapter. Let me check. I think it's chapter 4 or 5. Let me check it out. I think it's gonna be chapter 5. Let me check. To read it, but you don't need it for exam. But if you want to learn about it's too, you know, that book is really useful book and has so many other topics that I cannot cover in one like summer session. But yeah, if you look at, that's a really nice one. So yes, if you want to learn about it for sure, and if you have any questions, sure, for sure, but you can ask me. But yeah, I cannot teach all of this one in one, 1 month. 1 month and I don't know, 2 weeks. Something. Oh, chapter 14. Okay. Yeah. You're welcome. Anybody else does have a question? So